Hey guys! Today we're going to learn how to find the area of composite figures. Please take out your notebook because we're going to copy down some definitions and you guys are going to be copying down these examples. So first of all, a composite figure. What's a composite? Oh my god, it's spelled wrong. Composite figure. There we go. A composite figure, it's just a polygon that can be divided into multiple other polygons. So the polygons we've talked about so far are triangles, parallelograms, and trapezoids. A composite figure really isn't that different. Here's an example of a composite figure. Now technically, this is a trapezoid, but it's considered a composite figure because I could divide it right here, and now it's just a triangle and a rectangle. And you could find, instead of using the trapezoid formula, you could find the area of the triangle and then find the area of the rectangle and then add them together. Or I could divide it even more. I could cut this right here straight on this diagonal. Sorry, my line's not very straight. Pretend it's really straight. And now there's no trapezoid anymore. Now I just have one triangle, two triangles, three triangles, and I can find all three areas and add them together. So that's what a composite figure is. So we are going to practice finding the area of composite figures. So here's my first example. Now, this is a 1, 2, 3, 4. This is a hexagon because it has 6 sides. And I don't know what the formula for the area of a hexagon is, but it doesn't matter because I can divide this and I would draw my line right here and right here. Because look, now I have 2 triangles and a rectangle, and those are easy to find the area of. So let's do that. First of all, what's the area of this rectangle? Rectangle is probably the easiest one to start with because you just do length times width. So the width is 3, and the length is 1, 2, 3, 4. So we do 3 times 4 because the area of a rectangle is length times width. And that's 12. So that's the area of that part. Now I need to figure out the area of the triangle. Well, first of all, I notice that both of these triangles are the exact same size. So I don't need to find the area of both of them. Whatever this area is, it's going to be the same over here. So 1/2 times base times height, right? That's what I got to do. 1/2 times the base. Well, I can see right here at the base, I already figured it out. It's 4. And the height, just count up. 1, 2. So I multiply all these together. 4 times 2 is 8. And then 8 times 1/2 is 4. So that means that this area is 12. This triangle, that area is 4, which means this area is also 4. So to figure out the area of the entire composite figure, I'm just going to do 4 plus 12 plus 4. Which is 20. So the area of this composite figure is 20 units squared. Okay, so all I'm doing is taking the shape and I'm breaking it into other shapes that I know how to find the area of, and then I can add them all together at the end. So now that you know how to do those 3 shapes, you'll be able to find the area of everything else. So here's a composite figure, and technically this is a trapezoid. So I could use the formula for the area of a trapezoid, but I'm not going to because I'm going to practice doing it this way. So this right here is a square, which means that this side is also 8, this side is also 8, they're all 8. So to find the area of a square, you do length times width. 8 times 8, 64. So the area of the square is 64. Now to find the area of the triangle part, I'm going to do 1/2 times base times height. Well, the base right here is 11, and the height is 8 because it's opposite of this side right here. So 8 times 11 is 88. And then 88 times 1/2, well, what's 1/2 of 88? It's 44. So the area of this triangle is 44 centimeters squared. So to find the area of the whole thing, I'm just going to do 64 plus 44. And that equals, let's see, 108 centimeters squared. So that's the area of the entire composite figure. Now let's do one more. We have this composite figure here. Now there's a lot going on here. So technically it's one big trapezoid, but we don't have all the information. I do see though that I could do this two ways. I see a square here, I see a triangle here, and then I also see a parallelogram. But if I wanted, I could probably, oh no, I can't. Okay, so that's what we're going to have to do. We're going to have to find the area of the square, the triangle, and then the parallelogram. So let's start with the square. This square, so if this side is 9, that means this side also has to be 9. So 9 times 9, 81. So the area of the square is 81 inches squared. Now the area of the triangle. So we're going to do 1/2 times base times height. So the base I see right here is 6. And the height of the triangle is this line, which has to be 9 because it's opposite of this side. So 1/2 times 6 times 9. Well, 6 times 9 is 54. So what's 1/2 of 54? It is, let's say, 27. Okay, so that's the area of the triangle, 27. Now I'm going to do the parallelogram. So the parallelogram, remember to find the area of a parallelogram, we do base times height. Well, base, since this part is 8 inches, that means this is 2. So the base is 8 inches times the height. Remember, the height goes straight up. We know that it has to be 9 because this height going straight up is 9. In the middle here, this height going up is 9. So the height for the parallelogram is 9. So we're going to do 8 times 9, base times height. So the area of the parallelogram is 72. This is 72. So to figure out the area of the whole thing, we add them all together. 72 plus 27 plus 81. And what does that equal? Let's see, 72 plus 27 plus 81. I think, yeah, 180. 180, and then my units are inches squared. So that's a composite figure. And now that you know how to find the area of the small shapes, you can find the area of any shape. Just break it up into the shapes that you do know and then add them all together at the end. That's it. If you guys have questions, let me know. Bye.